Okay, so like I said, we are still talking about ellipses. That's why this one's called an ellipse part 2. But we're going to look at some problems where we have to work a little bit more with the equation and get it written in our standard form. So it's not already there. Like we have something that's got some of the pieces to it, but we don't have it quite ready to graph. And then when we get to graphing, we're going to handle that like we did the last couple of days. We're going to maybe start with the parent graph if our center has moved, and then just do our transformation in order to help us get the correct ellipse on our graph. So when we look at something written like this first one, where we've got all these terms like x's and y's, and we've got x squareds and y squareds, we're going to have to handle this like we did when we completed the square back when we were just dealing with quadratics. We did this when it was just dealing with x's, and we were trying to solve a quadratic equation. We used completing the square as one of our methods. So we're going to use that to help us do an ellipse. The first thing that you're going to want to do is group your variables together. So if you look up here, I have kind of my x squared term, my x term kind of separated, and I want those to be together. And so they put those down here. So now the 4x squared minus 32x are grouped together. They did the same thing with my y's, because my 9y squared and my 36y, those are also a little bit separated in my original form. So I put those together as well. Now what they did with the 64 is we want any constants, so anything that doesn't have a letter, we want that on the other side of the equal sign. So right now 64 is here, so we moved it over to the other side by just subtracting it. And that's why now it says negative 64. So that would be your first step, rewriting it so you're putting like terms together, get those x's together, those y's together, move any regular numbers you have over to the other side if it's not already there. Then we start to think about completing the square. And you notice how they put parentheses around those terms, and there's like these random blanks in the problem. The blanks are what we're going to be filling in when we do our completing the square process. To complete the square, your steps are to take half of your b term. Your b term is always that term in the middle in front of just the regular x or the y, so not the x squared term. So my b term for this first one is is a negative 8. Oh, and I guess I skipped over. They did take out a 4, so that's why it became a negative 8 here. I kind of skipped that step. So they factored out a 4, and then on the second one, they factored out a 9. But those terms that I'm boxing up there, the negative 8 and the 4, those are your b terms, and you can see down below how they're taking half of them. So that's step 1 is to cut it in half, and then step 2 of completing the square is to square that number. And they're kind of showing that to you all in one big step. They wrote negative 8 divided by 2 and then squared. So that would be negative 4 squared, which is 16. That 16 then goes in a couple of the blanks. It goes in this first one in the parentheses with the x, and then it goes in over here after the equal sign next to that 4. Because whatever we do to one side of the equation, we got to keep it balanced, and so we need to do it to both sides. So we can't just do it to one half and not reflect that on the other side there. Then they did the same thing with the y term. So my b for the y was that 4 that I boxed up here. They took 4 divided by 2, which would be 2, and then they squared that, and you get 4. And then again, that number goes in the parentheses with the y terms, and it needs to go on the other side as well. You can also see on the right side the 4 and the 9 that they factored out. Those are being reflected over on the other side as well. So anything that we do to manipulate the equation, we got to make sure that we keep it balanced and that it's equaling out on both sides of the equation here. After you complete the square and you get all those numbers filled into their blanks, how they go from this step to here is, if you remember with completing the square, the reason why we do this process is because it becomes a perfect trinomial that's really easy to factor. And to factor it, you just need to grab the x and then that number that was half of your b. So this negative 4 here actually came from this step up here that I did. It would also work the same way if you kind of thought through this. What numbers multiply to 16, add to a negative 8? negative 4 do that. Negative 4 times negative 4 is 16. Negative 4 plus negative 4 is negative 8. So you can also resort back to thinking through the factoring if you need to. The same thing happens here with my y's. If I think about two numbers that multiply to 4 and add to 4, the number would be 2, and that's this number that I have up here. And that's why it says y plus 2. Notice how the 4 and the 9 are still just kind of hanging out in the front of those parentheses. They don't just disappear, but they just kind of tag along to the rest of the problem. And then what's happening over on the right side is they're starting to simplify it. So they took 4 times 16 to get the 64, 9 times 4 to get the 36. Last thing they did is on the right side, because all of this just kind of dropped down, they didn't change anything there, is they saw that there was a positive and a negative 64. So they just canceled those out and we're left with 36. Now this form here, we have seen this in our ellipsis so far, where it wasn't equal to 1. And we had to get it equal to 1 by dividing by the number over there on the right side. So my last step here to get it in the equation that I need so I can actually graph this is divide everything by 36. Now remember, 4 cannot be divided by 36 nicely, but we can reduce it to 1 over 9. And that's why it became x minus 4 squared over 9 for my equation. Same thing happens on the middle. I can't take 9 divided by 36, but I can reduce that. So it's y plus 2 squared over a 4. And now it says equals 1. Now this is what we're used to dealing with. We saw this type of an equation yesterday. But again, I would maybe think about, because the center is not at 0, 0, let's pretend like it is. And let's graph this ellipse like it would be at 0, 0. And then we can graph the new one. When you look at this final equation here, what would be my a squared? The 9 is your a squared. So 4 is your b squared. Is this going to be a major vertical or major horizontal? Good. Major horizontal. I'm just going to abbreviate that MH over there. All right. If a squared is 9, that means a would be 3 and my b is 2. Good. Okay. I'm going to go ahead and start to think about finding my c squared, and then I'm going to get to graphing. C squared, remember, is to subtract a squared minus b squared. So 9 minus 4, which would be 5. But then you have to square root that for just c. And I would deal with the decimal if you can. I think we did square root of 5 yesterday, and it was 2.2. So I'm just going to write that down. Okay, I'm going to start graphing this ellipse now, centered at the origin. So my center is 0, 0. It's a major horizontal, which means the larger number, the a term, is going to go left and right 3. So I didn't write out the coordinates, but I'm going to look at my a term, and that's going to go left and right 3. So those are your vertices. The 2.2 is going to go along that same axis, because those are those foci. So that's going to be 2.2 on either side. And then the b is going to tell you like your co-vertices. You're going to go up and down from the origin to. Okay, so this is the before, the parent graph, basically. But that's not a true representation of the ellipse that we have. What's the center of the ellipse from way back up here? Up here, where's our center? 4, negative 2. So from the center here, my new point is going to be 4, negative 2, which means I'm going to move all of these points right 4 and down 2. And so I'm going to just move all of them. I'm going to shift them all that direction to get my final answer here. So there's my new center. That's the top covertice and the bottom covertice there. So that's kind of the up and down distance. Now I'm going to do those foci points and my vertices. I'm going to move them all Write 4 down 2. So this one here, I'll just highlight it. This is the one that I really care to see. But again, if you kind of like to use the parent graph to help you, that's why I graphed that one in red first. And then over on the other side, they are asking like, what are the vertices? What are the endpoints of the minor? Those focus points. So now that we have it all graphed, it'd be really easy to grab all those coordinates. So I'll just write those down really quick. My vertices would be at 1, -2, and 7, -2. The minor endpoints, one would be at 4, 0, and 4, -4. And then those foci points. 6.2, -2. And then 1 point, oh no, hold on. It'd be like -1 point. It was, this was 2.2. Would it be 0.8? Oh yeah, positive. Because it did move over. Okay, and then still -2. I had to think about that one for a second. Okay, so all we're doing differently today is we're completing the square first, and then we're graphing it like we did yesterday. So I've got one more to work through here, but we're going to kind of go through it from scratch. All right, so what should we do first? Separate the exponents, or the x's and y's, you're saying? Okay, and I'm going to add in all my blanks. Okay, so my x squared can go with my 10x. And then there's going to be a blank here. The 4y squared goes with the -8y. And then another blank. Okay, I want to move that 13 over to the other side. So I'm going to subtract it. So now it says -13. And then I need to have 2 blanks after that, because on the left side I have 2 spots that I'm going to be filling in. So I got to reflect that. From the x's, there's no number in front of the x squared, so I don't need to worry about trying to take anything out. But from the second one, let's take out that 4 that's in front of the y squared. So I'm not going to change anything for this first piece. But if I take a 4 out, what would that leave me with on the inside here? Good. And then over here, with the second blank after the -13, I'm going to have to reflect what I just did there. So I'm going to put a 4 in front of it. That way, whatever I fill in with that completing the square, because I removed the 4, that impacts the math. So I got to reflect that over there on the right side to keep it balanced. All right, so now let's start completing the square. So you're taking half of 10 and dividing by 2, and you're squaring it. So what's that going to be? 25. So that's going to go in this first blank and the first one after the -13. And then over on the second one here, we're going to take -2 divided by 2 and square that. What is that number? Just 1. Okay. So how will this first set factor? Again, you can think, what are 2 numbers that multiply to 25, add to 10? 5 and 5. So this would be x plus 5 squared plus 4. How does this one factor? multiply to 1, add to negative 2. Those wouldn't. What numbers multiply to 1? 1 in itself, right? If they want to add to a negative 2, though, they should both be negative. So y minus 1 squared. And then over here, we would have negative 13 plus 25 plus 4. What is that? 16. So this equals 16. Okay, I need to divide by that 16, though, to get it to equal 1. And then we should have an equation that we can work with here. If I divide the first one by 16, nothing's going to happen. It's going to be x plus 5 squared over 16. What's going to happen on the next one? Yeah, we'd be able to take out the 4. So if you take 4 out of 16, if you divide it, what are you left with? 4. And then equals 1. Okay, so you've got your equation now. What's my a squared? 16. B squared is 4. So it's a major what? Good, horizontal. So A would be 4, and your B is 2. C squared would be 16 minus 4, which is how much? 12. And we got to square root that. What is the square root of 12 about? 3.4? Okay, now we can graph. So I'm going to start by graphing again at the origin. I'm going to scroll down. I hope that's okay. So we said our graph is a major horizontal, so it's going to be an ellipse kind of stretched out left to right. The A was 4, so we're going to go left and right 4. We said the foci was 3.4, so I'm just going to roughly estimate where I think that is. And then those co-vertices are up and down 2. So there's, the parent. Okay, but what was the center of my equation from up here? Negative 5, 1. So I'm just going to write that off to the left side here. My center of the new one is negative 5, 1. So it's going to move all those points left 5 and up 1. So let's go ahead and do that. Okay, so again, this is the one that we needed to make sure we ended with over here. That's the final one. Where would be my new vertices?
Negative 9 and 1.
Mm-hmm.
And then negative 1 and 1.
The foci points?
Negative 8.4. And then 1. And then negative 1.6.
Good. And then those endpoints of the minor, or those co-vertices would maybe be another name for that. Good. Questions on the completing the square with the ellipse like that?